Okay. All right. So let's go back. We have Hess's law is an expression of the principle of conservation of energy. So we have the enthalpy, also expressed in the first law of thermodynamics, and the fact that the enthalpy of a chemical process is independent of the path taken from initial to final state. So if we have, so the total enthalpy is the enthalpy of the product minus the enthalpy of the reactant. So energy from product minus the enthalpy of the reactant. Okay, so we have that one. Okay, so we also have ionization energy. Okay, ionization energy, we've talked this already. It's the minimum energy required to remove an electron. So we have this equation. We put an energy to the reactant, and then we have an electron being dissociated. Okay, we have an electron dissociated from an atom, or in the product. We have electron in the product. Now, ionization energy increases as one moves from left to right within a period. Okay, so if we have periodic table, now who has higher ionization energy? Mg or sulfur? Hello?
Sorry for ma'am.
We have, okay, we have sulfur. Okay, kana. Alright, so that is, now because ato pong gistoryan sa una that atoms with low ionization energy tends to form cations. So tend to form cations. Low ionization energy tend to form cations, and higher ionization energy tends to form anions. We also have IE also decreases as one moves from down any group. IE decreases as one moves from down any given group. So as we go down, ionization energy, as we go down, ionization energy also decreases. So if we have francium and then we have potassium, who has higher ionization energy? Who has a higher ionization energy?
Potassium ma'am.
Okay. Okay, we also have electron affinity of an atom or molecule. Okay, it's the amount of energy released. Okay, the energy you release. Energy nga imong ipagawas. Katong isa, energy affinity ionization is energy nga imong kinahanglanon to remove an electron. Now, electron affinity is opposite. Affinity is ang energy nga imong ipagawas when you add an electron. Okay, so that's why we have an energy as a product and a electron as a reactant. So take note of that. We have that here. Okay. So, mailhan na ninyo, makailan na mo. So, the ionic bonding is naano siya sa Born-Haber cycle. Is illustrated using Born-Haber cycle. So we have first is we have lithium and then we have fluorine. So in the first step, this is step 1. Okay. Gas. Solid lithium. 1, 2, 3, 4, 5. Lithium. First step is we have step 1 is the conversion of your lithium, solid lithium to gas. Okay, so it's first converted to solid lithium from solid lithium to gas. That's step 1. And then step 2 is we have F2, no? We have F2. F2 is dissociated. So, imuhang gi-break down ng F2. If we have F2, imo na siyang gi-break. Okay? Forming 1F. So, like in this case. So, step 2 is dissociation. Now, step 3 is what happened to your lithium is that it is being ionized. Name mo na siyang ion. So, it's step 3 is the ionization of your lithium, and we have also step 4 is all still an ionization of your fluorine, and then after that one is the bonding or ionic bonding of your lithium fluoride. So first is the conversion of solid to gas, and then dissociation of your F, and then ionization of the two, and then forming your chemical now, which is lithium fluoride. Okay, this one. So we have here, we have lithium. Okay, lithium to gas, F2 to F, dissociation, lithium to lithium ion, that's ionization. Then we have this one, addition of electrons to your fluorine, and then forming lithium plus fluorine, which forms lithium fluoride. One is 7. Okay, wait a minute sa. A minute. Okay, so we have this one. Now, if we have sodium chloride, okay, if we have sodium chloride, now the first thing to do is, first step is we have, what's itong first step? Conversion. So in this cycle or illustration, we are going to look what happens to ionic bonding. It's dili siya diretso. there are five steps pag gihapon iyang sundon. First is we have conversion. Kung we have an SAL no kay diretso na to ano na transfer of electrons, but there are five steps happening pa yun. We have first conversion. Your solid will be converted to gas. Then the chlorine will be dissociated. I-dissociate ni mo na silang duha. Then the sodium will become ionized, and then the chlorine also, okay, the chlorine ion will be formed. Okay, still an ionization of your, okay, this is not an ionization. Okay, Cl will be formed. Cl ion will be formed, and after that one, if we have no ions, we have a cation ion, and then we have an ion. Okay, we have this one and we have this one. Then we can form an ACl, ionic bonding. Now, going back to Hess's law, which states that enthalpy delta HO is equal to the sum of enthalpy formation minus enthalpy sum of enthalpy. Or we have this product minus reactant. We have uh, now if you are going to add that one, wait, so products minus reactants. Okay, negative, so we have product which is negative. So if you're going to calculate that one, the enthalpy in the product, kanina ka sa blue, step 4 and 5, the enthalpy is negative 348.6 kilojoules per mole plus negative 787 kilojoules per mole. That is equal to negative, pila na siya class? Negative, negative 348.6 plus negative 787 kilojoules. That is equal to negative 1135.6. Then we add also, because it's the sum of the enthalpy in the reactants, which is equal to step 1, 1107.3. Hello, napako. 107.3 plus 122 plus 495.8 kilojoules. That is equal to, okay, that is equal to 725.1. Okay. So then let's calculate the enthalpy we have, or the lattice energy, for because this is ionic bonding. Okay, we have 1135.6 minus the reactant, which is 725.1 kilojoules per mole. That is equal to Negative. Saan mo? Which is equal to, wala. Nakaligo na day ka. Hello?
410.51.
Okay, we have that one which is equal to 400, negative 410.5 kilojoules per mole. Panakay ninyo guys. Okay, so this one, the negative sign here is, it means that it is exothermic reaction. Exothermic reaction, while the positive sign here, it means that is endothermic reaction. So the formation of your NaCl is an exothermic reaction. That is why it is negative 411. So in this case, the negative sign only means that is exothermic reaction. Okay? So exothermic, it means that energy is released. Okay, so we have that one. Okay, now let's go to periodic trends in lattice energy. So lattice energy is affected by anionic size and ionic charge. So the lattice energy, okay, if the size is big, okay, we have that one. As ionic size increases, lattice energy also decreases. Lattice energy therefore decreases down a group on the periodic table. So the lattice energy is affected. So lattice energy is the energy this one. Katong gi-calculate nato kaganina. All right. So this one is the lattice energy. Energy. So as ionic charge increases, lattice energy increases. So if we have, okay, energy required to separate 1 mole of ionic solid into gaseous ions. Remember that in ionic bonding, we have 5 steps. We have from first is conversion. So conversion of your sodium, solid sodium to to gas, that requires lattice energy. The energy required there is lattice energy. So we have, it says that energy, okay, and if we have this Coulomb's law, the Coulomb's law, which is in your physics, electrostatic energy is proportional to the charge of A. If we have A here and then the B here, so the charge of A and B is directly proportional to electrostatic energy and is inversely proportional to the distance. If taas imuhang distance, layo, taglagyo kayo ang A and B, then the attraction also decreases. The electrostatic energy, or the energy that attracts each other, decreases because of the distance. Now, the same thing also happens to your atoms. The cation charge, okay, cation and anion charge. Because this is ionic bonding, we have cations and then we have anions. Now, cation charge and anion charge, if it is large, then the electrostatic energy also increases, and also the lattice energy increases. However, if the size or the radius is also big, then the lattice energy decreases. Okay? Okay pa? All right. So what will happen if dako kayo ato ang charge? Okay. What will happen? Okay, so who has higher lattice energy? Barium, strontium, or rubidium? Hello?
Strontium, ma'am.
Okay, because it has higher charge. Now, what about the lattice energy of your calcium and strontium? Who has higher lattice energy?
Calcium, ma'am.
Higher lattice energy. So they have the same size. They have the same charge, no, positive 2. However, if we, okay, sa to. So same positive 2 na, no, positive 2. S- So unsa tong next tan-awon is the size. Who is bigger? Calcium, strontium. Who is bigger? Calcium, strontium.
Strontium, ma'am.
Okay,
Ma'am.
strontium. All right. Strontium. So we have strontium is bigger. So therefore, between the two, who has higher lattice energy?
Calcium, ma'am.
Calcium. Okay, calcium. So just don't forget this formula. So we have that one. Okay, basa lang mo ha. Okay, we have that one. When bond is formed, when we form a bond, energy is released. When we break a bond, huh? Energy is absorbed. Opo. So we have also bonding pairs and the lone pairs. Atoms share electrons to achieve full outer level of electrons called shared or pair or bonding pair. Okay, this one or this one, this is Lewis. Lewis dot structure. This one is line bond structure because it has line bond structure. An outer level electron pair that is not involved in bonding is called a lone pair or unshared pair. If it is not included, then it is a lone pair. Say for example, sodium. Okay. How many valence electrons for your nitrogen?
5, ma'am.
5. How many electrons will be involved in chemical bonding?
3, ma'am.
3. This one, for example, H. H, and H. No? If we have that one. Now, what do you call this one? We call it a lone pair. Involved in but electron, although it's an outer level or it's part of the valence electrons, but it is not involved in bonding, it is called lone pair. Kanina sila is shared pair, shared pair, shared pair. Shared electrons or shared pair. Bonding pair, and this one is the lone pair or non-bonding pair. Non. So we call that lone pair. Now we also have bond energy is the number of electron pairs being shared by a given pair of atoms. Bond order is the number of electron pairs. Number of electron pairs being shared by given pair of atoms. Okay, so if we have single bond, how many bonding pair? By how many bond order? What's the bond order? The number of electron pairs. If we have NaCl, what is the bond order? In one bond, how many electrons?
One, ma'am.
One? No, di ba kanina, from sodium, electron from sodium, electron from chlorine. So we have, in every bond, we have how many electrons? Two. 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 Okay. So what is the bond order in NaCl? Bond order is number of electron pairs. How many electron pairs? How many electron pairs?
One, ma'am.
One. Okay, one electron pair. Paris ba? Paris. Isa kaparisan. So we have bond order. BO is equal to 1. Okay, because it is consist of only one bonding pair. Now, what if we have C double bond C, and then we have H, H, H. Okay, if we have ethylene, how many in CC bond? Okay, only look for CC bond, huh? CC bond, C and C. How many bonding pair? How many bonding
Four,
pairs? Kanirang C o C? CC. One bonding pair. Kani siya kay one bonding pair man ni siya. One bonding pair. Then bond order
two,
1.
ma'am.
One bonding pair. Okay, 2. We have one bonding pair and the second bonding pair. Now, what is the bond order? What's the bond order?
Four, ma'am.
Di ba ang bond order is an electron pairs? Number of electron pairs. Kani, isa man ni sila kaparisan. 1, 2. Kay duha man na, 1, 2. So, first pair, second pair. So, what is the bond order?
Two, ma'am.
2. Okay. So what if we have one, two, three? Oh, how many? What is the bond order?
3, ma'am.
One, two, three. In one bond, how many electrons?
2, ma'am.
Two. Okay. So take note of this statement. A single bond consists of one bonding pair and has a bond order of one. So if we have a double bond, how many bonding pair?
2, ma'am.
How many bond order?
2, ma'am.
So if we have triple bond, how many
3,
bonding
ma'am.
pair?
3, ma'am.
Three. Okay, and
3, ma'am.
three. The bond energy is the energy needed to overcome the attraction between the nuclei and the shared electron. Stronger the bond, the higher the bond energy. Stronger the bond, the higher bond energy. Okay, who is no? Who has a stronger bond? NECL or this C double bond C?
Double band C, ma'am.
Okay, duha na good murag hawid bag PC. Strong tong duha ka buok. Okay. So, if you're going to arrange the three molecules in ascending order in terms of strong uh higher bond energy, highest bond energy, ascending, first molecule, second molecule, third molecule. We have ascending.
NaCl ang una, ma'am.
NaCl,
Dayon ka ng double band C. Dayon triple band.
C2H4, then C double bond C, no? C triple bond C. Okay, higher bond. The stronger the bond, the higher the bond energy. Bond energy is the energy needed to overcome the attraction between the nuclei and the shared electrons. Okay, bond length also is the distance between the nuclei of the bond atoms. Okay, if we have now, what will happen to the bond length? Okay, what will happen to the bond length? Ang kataas sa bond if taas ang imuhang bond energy. Again, the bond energy is mao na imuhang energy needed to overcome the attraction. The attraction of the nuclei of the first atom and the electron to the second atom. So kato nga mao to siya imuhang bond energy. Now, if taas ang imuhang bond imuhang high if taas imuhang energy, then what will happen to the bond length is it will become mugamay siya because the electron will be pulled to the nucleus. It will be pulled. So, ang imong length mo gamay. Okay. So, who has higher bond length? Triple bond or single bond?
Single band, ma'am.
Single bond. Okay, single bond. So we have that one. Okay, study lang mo ha. Higher bond given pair of atoms, higher bond order results to shorter bond length. Okay, sakto. And higher bond energy. Okay, example, higher bond order. If we have three bond orders, so meaning triple bond, results in a shorter bond length. If you have triple bonds, mugamay imuhang bond length. And what will happen to the energy? It is greater. Great shorter because also triple bond man siya. Taas ang energy, then the bond length will be shorter. Okay. The given pair of atoms shorter bond. For a given pair of atoms, a shorter bond. Okay. A shorter bond. Okay, yes. A shorter bond is a stronger bond. So who has a stronger bond? Single bond or double bond?
Double bond.
Double bond. And who has a shorter bond? Double bond, single bond.
Double bond.
Okay,
Double band,
double
ma'am.
bond. Bond length increases down a group in the periodic. Okay, if you are going to look on the periodic table, the bond length increases. Okay, down a down a group. What will happen to the bond length? It will increase. Why? It will be affected by, diba, if we have this one, 7, no? 1, 2, 3, 4, 5, 6, 7. Take note of the bond length from electron to the nucleus. Taas kayo if we have higher, if we have n is equal to 7. But if n is equal to 1, gamay mo ang bond length. Okay, so, pasabot. Okay, we have francium has higher bond length compared to sodium. Bond, okay, and decreases across a period. Why? Across a period, what happened to the size of your elements or of your atom if we go across a period from left to right? From left to right, moon sa imuhang size sa imuhang atoms, we have mugamay mo
Mo increase, ma'am.
decrease. It will decrease. Okay, because it is not affected by shielding anymore. We have what the shield 1, shield 2, shield 3, shield 4, shield 5. But if across a period, no shielding, naara diri ta ng electrons, electrons here, electrons, or adding a period naara diri na. No shielding. If we have n is equal to 1, no shielding. So mugamay ni siya diri dapita because greater nuclear charge also. Greater nuclear charge, the attraction of your nucleus and then your electrons. Nuclear charge. So, what will happen to the bond length across a period? It will decrease. Kay mugamay man ang imong size sa imong atom. Bond energy shows the opposite trend. Okay, alright. Alright, as we can see here, the bond energy, we have that there. Double bond, bond order 2. Okay, triple bond 3 ang bond order. So, again, now molecules move and stretch in a linear way. Then we also have nonlinear or bending. Okay. We have then the NMR or IR spectrum because each spectra, okay, if this one, we can identify what bond is that. Okay, here also, this is CH bond. If we have a very stretched na spectra, then that is C triple bond N. So each spectra, if you go to higher chem, then you will read each spectra. Okay, kani siya, ano ni siya? C double bond C ni siya. Okay. Kani unsa ni nga bond. So, you will be taught how to read that one. Okay, this one also you are going to read. Okay, what molecule is present if we have that spectra. Okay. So we have again bond energies also heat released or absorbed during when We form a bond. What happened to energy? Energy is released. And when we break a bond, energy is absorbed. Okay, don't forget that one. So we have that one like here. So no no in breaking the bond, because we have blue and blue two. Okay, we have blue two. If we're going to break that one, then we need an energy. That's why it's positive 432. Okay, bonds broken 491. Okay, but if we are going to form a bond, so if we are going to form a bond, that is an exothermic reaction, heat is released. So that is negative. That's why kaganina when we form the NaCl, we have a negative sign on the product side because the energy there is being released. It is exothermic reaction. Just like the same here. Just just like here, which is also negative, meaning heat is released. Exothermic reaction, and we have endothermic reaction. Okay, we have that one. Now, calculate the energy bond energy for the chlorination of methane from form chloroform. Okay, we are going to calculate the total bond energy. So delta H. Okay, we have first is product, okay. Formed, product formed minus product minus broken. Okay, first is in this case in CH4, how many bonds in CH4? First bond, second bond. Okay, third bond. So we have fourth bond. So we have 4 CH bond. Now, what is the bond energy of CH? Let's take a look on the table. Naman to. CH. Okay, we have here. The bond energy of CH is 413. So we have 413 times 4 because there are 4 CH bond, that is equal to, calculate daw.
Times, ma'am.
Oo, times.
1,652, ma'am.
1,652 kilojoules per mole. So that is the energy needed to break the bond. To break nga, baskago ni mo ni sila tanan. So you need 1,652 kilojoules. Then, also, napatay Cl. Cl bond. Let's go to the bond energy of Cl. Say ClCl.
243, ma'am.
Wait, asa tapit? Alright, here. Bond energy, which is 243. So we have, okay, 243. Now, how many ClCl bond? We have 3. Oh, 3.
3, ma'am.
3. Look.
Ay, 3 din.
Okay. we have 243, no? 243 times 3 pila. That is
729.
okay.
729.
Okay, now you sum that with 1652. A total of
2,350, ma'am.
2051.
381.
Okay, so this is the total energy needed to break the bonds. Now, what about here on this side? First is how many bonds? We have CH bond. Only one ang CH bond. What pilan sa ito bond energy sa CH? 413. We have 413. Then we have the CL. CCL. How many CCL bonds? 3.
3,
3, ma'am.
3 now ang itata sa CCL. CCL. Good.
339.
CCL. Oh God. Tara. 339.
339, ma'am.
So 339 times 3. That is it.
1,017, ma'am.
Okay, what about HCl?
427.
Oh, times 3. Because we have 3.
1,281, ma'am.
1,281. Okay, total daw ni sum.
$2,711, ma'am.
2,711. So we have, okay, to get the total bond energy or the delta bond energy is we have bonds broken. Then we add that to 1. We add to the bonds being formed. Okay. So why is it that it is negative? Okay, plus to class. Delta H is equal to bonds broken 2,381 plus. Now, remember that this is bonds formed. This is an exothermic reaction. Don't forget to put negative sign. Negative. And then we have negative. So we have negative also here. So that is equal to negative 2,711. So delta bond energy is equal to to
Negative 330, ma'am.
negative 330
30.
kilojoules per mole. Don't forget the unit. Okay, so this is the energy released when we form this molecule CCl3 H. Okay, this is the energy needed to be released. That is 330 kilojoules. Okay, we have also bond. Okay. We also have electronegativity and bond polarity. Hapit na ta. Covalent bond in which shared electron pair is not shared equally. So if we have covalent, now let's talk to covalent bonding in which, okay, when we say covalent bonding, diba, it is sharing of electrons. However, their electronegativity affects sharing. Okay, electronegativity affects sharing of electrons. Electronegativity is, diba, it's katong who is stronger. Okay, it's on who is stronger, oxygen and fluorine. Fluorine stronger than oxygen. Okay, so this one, if that's the case, then sharing will not be equal. Sharing will be unequal. Now, shared electron pair is not shared equally but remains closer to one atom. Okay, so the electrons remains closer to one atom than the other. That is polar covalent bond. Okay, we have polar covalent bond. The ability of an atom is covalent bond to attract the shared electron pair is called electronegativity. An equal weight sharing of electrons causes the more electronegative atom of the bond to be partially positive and partially negative. Okay, so for example, if we have okay. All right, if we have H, okay, one valence electron, and then we have Cl, okay, seven valence electrons, three lone pairs, okay. So we have that one. Now we know that H will be shared, and the electron from chlorine also will be shared, forming HCl. Now, however, who has higher electronegativity? Cl or H? Electronegativity.
CL, ma'am.
So yes, so it is,
CL ma'am.
okay. If we go across the table, as we go across the table, electronegativity increases. So we have Cl because Cl is stronger or has higher electronegativity than hydrogen, so the electron from hydrogen will be pulled closer to, okay, the two electrons will be pulled closer to Cl, forming so that's why the arrow will have, okay, the electrons will have, they have an arrow which goes towards the Cl because it means that the electrons are pulled or goes toward the Cl. And if that happens, the H will become partially positive and the Cl will become partially negative. Then this is now the reason that the HCl, if we have polar covalent bond, that it is more reactive. Pag once it is polar, more react na dayon siya because we have the partially negative and partial positive signs. Okay, again, the electrons are not shared equally. So maybe if we have murag balloon ba electron density, gamay ra dira, and then the electrons are here, here. So dako kay siya nga side sa Cl kaysa sa imuhang H because the electrons are pulled by the stronger one. So electrons, we have that arrow. Now, if we have HF, okay, HF, so we have HF, so the arrow goes to fluorine because fluorine is partially negative and now hydrogen is partially positive. So take a look on this one. This is for pure ionic. Now for cations, we have cations, the electrons in the cations. Now as you can see, the electron density, so mas taas ang makita nimong probability sa imo ang sa imong electrons in the cation side, so because it has higher electronegativity pod. And second, first reason is that the electron from cations are shared, are transferred to the anion. So murag bunda ko ihang density sa imuhang anion. Now if we have polar, okay, if we have pure covalent, now the electrons are shared equally. Look at the density, look at the lobe, okay, parihara. However, if we have polar covalent, now it's bigger on the other side, it's bigger on the higher electronegative atom because it's partially negative, and it has an arrow like this one if we want to say that it is covalent or it is polar. Okay, so polarity, okay, so trends in electronegativity increases as we go down across the table and decreases as we go down. Okay, it decreases down a group and as atomic size increases. Okay, as atomic size also increases, it decreases ang imong electronegativity. Again, it is affected by shielding. In general, electronegativity increases across a period as atomic size decreases. Nonmetals tend to be more electronegative than metals. So we have partially, that's why when we have polar covalent, so nonmetals are partially negative and metals are partially positive. Hello? Who has higher electronegativity, calcium or fluorine?
Marine, ma'am.
Okay, fluorine. Fluorine has the highest electronegativity. Okay. Electronegativities can be used to assign oxidation numbers. Okay. The less electronegative atom is assigned none to shared electrons. Each atom in a bond is assigned all of its unshared electrons. So we have this formula for oxidation number: valence electron minus shared plus unshared. Okay, if we have HCl, okay, is this polar or non-polar? Polar or non-polar?
Polar, ma'am.
It's polar because Cl is very electronegative. Another example of non-polar, which is pure covalent bonding, is we have CH. Okay, CH. It is non-polar. All right. So we have, now who is positive, partially positive in HCl?
H, ma'am.
Partially negative. Okay, the arrows goes towards the Cl. Now, Cl is more electronegative than H. So for Cl, now let's take a look for the oxidation number. Oxidation number of your Cl. Now, first is valence electron. How many valence electrons for Cl? We have 7. Then, how many shared electrons?
2.
2. 1 and 2. Because, yeah, naman po na. Sa Cl naman po ding electron sa H because they are shared. Kung unsay nasa isa, imuha na. Kung unsay imuha, isa-isa na. Okay, so it is shared. So we have 2. Then how many lone pairs or unshared?
6.
We have 6. Okay, now we have this formula. So the oxidation number of your Cl minus is negative 1. Then what about your H? Let's take a look for H. H is less electronegative than Cl. So for H, the valence electron is equal to 1. Then how many shared electrons?
0, ma'am.
How many shared electrons? Di ba duha man unta kani 1 and 2. However, we have the rule. Less electronegative atom is assigned none. None of the shared electrons. So, none of the shared. So, di man na to siya assign none. Bisag duha unta to. So, we write 0. Then, what about the unshared?
0.
No, okay. No unshared electrons na. Okay. Isa ra ba ang valence electron sa H? So, we have oxidation number of your H is positive 1. Okay. We have HF. Okay. Is this correct? Is the arrow correct?
Yes, ma'am.
Okay. Is the partially positive and negative correct?
Yes, ma'am.
Okay. Alright. What about the oxidation number of F? Okay, let's get. So 7 valence electrons minus number of shared electrons.
1, ma'am.
1, 2,
2.
2 plus katong
Plus 6.
okay plus 6 unshared electrons. So that is equal to 7 minus 8. That is equal to oxidation number, which is equal to
Positive.
negative 1. Okay, so we have, now take note of this range. If we have electronegativity to change in electronegativity is, if we have less 0.4 below, then that is pure covalent. It's non-polar. Wait sa hakos.